Let me ask you something. How much are you worth? Not your house, not your savings account, not the car you drive. I mean you, the physical material that makes up your body. If I could take you apart, atom by atom, and sell the raw ingredients on the open market, how much money would I get? About $1.50. Maybe a little more if the market's good. You're mostly oxygen, carbon, hydrogen, and nitrogen. Cheap stuff. The oxygen and hydrogen are basically water, and water you can get from a tap. The carbon, that's pencil lead. The nitrogen, that's fertilizer. You've got a little calcium in your bones, a pinch of iron in your blood, a whisper of phosphorus in your brain. Add it all up, and you're worth less than a sandwich at a deli counter. That's not the horrifying part. That's just the setup. Stick with me. See, here's what most people think when they imagine what happens after they die. They think of the body as a thing, a solid, permanent object that happens to stop working, like a car that runs out of gas. The engine quits, the car sits there, and eventually it rusts. Slow, gradual, dignified even. Physics has a very different story to tell, and it's not dignified at all. Let's start with what you actually are. Right now, while you're alive and listening to me, you are approximately 7 billion atoms. That's a 7 followed by 27 zeros. Try writing that number down sometime. You'll run out of paper. And these atoms, they're not just sitting there. They're moving, vibrating, colliding. Every atom in your body is doing something. The water molecules in your blood are tumbling past each other at hundreds of meters per second. The proteins in your cells are folding and unfolding thousands of times a second. There is an unbelievable amount of organized activity happening inside you at this very moment. And I want you to notice that word, organized. That's the key to everything I'm going to tell you. Your body is not remarkable because of what it's made of. A bucket of seawater has most of the same elements. What's remarkable is the arrangement, the specific, extraordinarily precise arrangement of those 7 billion atoms into molecules, into proteins, into cells, into tissues, into organs, into you. The odds of those atoms falling into that arrangement by chance are so small that there is no number in ordinary language to describe how unlikely you are. You are a statistical miracle. Right now, sitting there, you are the most improbable arrangement of matter within 100 miles of where you are. But here's the part that should start making you uncomfortable. Those atoms, they're not yours. I remember reading about an experiment, a beautiful experiment with radioactive phosphorus. Scientists fed rats food containing phosphorus atoms that had been tagged, made radioactive so you could track them. They wanted to know how long the phosphorus stays in the brain, and the answer was about 2 weeks. Half of it is gone in 2 weeks. The phosphorus that is in your brain right now is not the same phosphorus that was there last month. The atoms get swapped out. Old ones leave, new ones come in. And this isn't just phosphorus, it's everything. Your entire body replaces nearly all of its atoms over the course of roughly 7 to 10 years. The calcium in your bones right now, it used to be in the soil. Before that, maybe it was in a tree. Before that, maybe it was in a fish. The iron in your blood was forged inside a dying star billions of years ago. And between then and now, it has been in volcanoes, in oceans, in plants, in other animals, in the dirt. It just happens to be passing through you at the moment. So what are you? If the atoms are always changing, if the material is always being swapped, what makes you you? The answer is the pattern. You are not a thing. You are a process, a dance. The atoms come into your body. They do a very specific dance, a dance called being you, and then they leave. New atoms come in and do the same dance. The dance continues. The dancers are always different, but the choreography persists. That's what being alive means, from the point of view of physics. You are a pattern that maintains itself, a whirlpool in a river. The water flowing through a whirlpool is always different water, but the shape of the whirlpool stays the same. You are like that. You're the shape, not the water. And this brings us to the terrifying part, because a whirlpool only exists as long as the river keeps flowing. Your body, every second of every day, is fighting a war. And the enemy is the second law of thermodynamics. This is the law that says disorder always increases, always. In any closed system, things move from order toward chaos. A hot cup of coffee cools down. A sandcastle crumbles. A house left alone starts to fall apart. The universe has a direction, and that direction is toward a mess. Everything in nature tends toward the most probable state, and the most probable state of your atoms is not a living human being. The most probable state is a warm puddle of simple chemicals. The number of ways to arrange your atoms into something that isn't you is so incomprehensibly larger than the number of ways to arrange them into you that the comparison is almost meaningless. So how do you survive? How does any living thing survive against those odds? By eating. That sounds absurdly simple, but it's the deepest truth in biology. The physicist Erwin Schrödinger thought about this very carefully back in 1944. He asked the question, what is life from the perspective of physics? And his answer was strange and wonderful. He said that a living organism feeds on negative entropy. What on earth does that mean? It means you take in food which is highly organized, low entropy matter. A potato, for instance. A potato is a complex arrangement of starch molecules, proteins, vitamins, water, held in specific cellular structures. That's order. That's low entropy. Your body breaks those molecules apart and uses the energy and the structural information contained in them to maintain your own organization. You rearrange the atoms in that potato to repair your cells, build new proteins, keep your heart beating, keep your neurons firing, and then you excrete waste, which is disordered, high-entropy junk. Carbon dioxide, urea, heat. You breathe out simple gases. You radiate warmth into the room. You are an entropy pump. You suck order in through your mouth, and you push disorder out through every pore and every exhaled breath. That is what metabolism is when you strip away all the biochemistry textbook language. It's a machine for importing order and exporting chaos. And the numbers are staggering. Your body burns through roughly 2,000 calories a day just to maintain its structure. That's not exercise. That's not thinking hard. That's just the cost of staying organized. 2,000 calories of highly ordered chemical energy converted into heat and waste every single day just to keep the second law from winning. You've been doing this since the day you were born. You will do it every day until you die. The moment you stop, even for a few minutes, things start to go wrong. Every bite of food you eat, every breath you take, is ammunition in the war against the second law. And the moment you die, the war is over. The second law wins, not gradually, not slowly, immediately. The instant your heart stops, the instant your metabolism ceases, the organized chemical reactions that held everything together stop. And what happens next is what the second law has been waiting to do to you your entire life. It goes to work. Within minutes, the cells in your body begin to digest themselves. Without the constant input of energy, the enzymes that were carefully regulated, kept in their proper compartments, start leaking out. They don't know you're dead. They're just molecules. They do what they've always done. They break things apart. Only now there's nothing stopping them. Your own enzymes begin dissolving you from the inside. The bacteria in your gut, billions of them, have been held in check your whole life by your immune system. Within hours, they start to spread. They eat through the walls of your intestines. They consume the tissues around them. These are organisms that lived inside you cooperatively, and now they're just eating. The chemical barrier that separated inside from outside is collapsing. Your body temperature drops to match the surrounding air. This is just heat transfer. Simple, brutal physics. The thermal energy that was carefully maintained at 37 degrees, a temperature your body spent enormous resources keeping constant, dissipates. You cool down. The molecules slow. The carefully tuned chemical reactions that required that specific temperature to function would stop, even if they hadn't already. And then decomposition takes over in earnest. The complex organic molecules that make up your tissues, the proteins, the fats, the nucleic acids, these begin to fragment. The chemical bonds that held them together break, not because something breaks them, but because those bonds were always thermodynamically unstable. They only existed because your body kept pouring energy into maintaining them. Without that energy, they fall apart on their own. The second law doesn't need a hammer. It just needs you to stop paying attention. Within weeks, the molecules that were you have been broken down into simpler and simpler forms. Amino acids, sugars, fatty acids, eventually even those break down. Carbon dioxide, water, ammonia, methane, simple, small, common molecules. The organized complexity that was your body is being converted step by step into disorganized simplicity. And the speed of this is what shocks people. We think of decomposition as something that takes years, headstones and old bones and fossils, but the physics doesn't care about our feelings. In warm conditions, most of your soft tissue is gone in a matter of weeks. The chemical energy stored in your body, all those complex bonds and all those organized molecules gets released, converted to heat, radiated away, gone. Remember, your body contained roughly 2,000 calories worth of organized chemical energy that it burned every day just to maintain itself. Well, all the remaining stored energy, all the fats, all the proteins, all the carbohydrates that you had stockpiled, now gets released too. Not in a controlled way, not through careful metabolic pathways, just raw chemistry, oxidation, fermentation, bacterial digestion. The energy that was you gets dumped into the environment in the most disorganized way possible. And here's what happens to those atoms. This is the part that really got me when I first thought about it carefully. Your carbon atoms, the ones that made up the proteins in your muscles, the DNA in your cells, they're released as carbon dioxide. They drift into the atmosphere. A tree absorbs one. That carbon atom becomes part of a leaf. A caterpillar eats the leaf. A bird eats the caterpillar. A year from now, an atom that used to be part of your brain might be part of a sparrow's wing. Your hydrogen and oxygen atoms, most of them were water, they evaporate. They join a cloud. They rain down somewhere else. They end up in a river, in an ocean, in another person's drinking glass. Your water becomes someone else's water. Your nitrogen goes back into the soil. It becomes fertilizer for grass. A cow eats the grass. Someone eats the cow. The nitrogen that was part of your thoughts is now part of someone else's lunch. This isn't poetic exaggeration. This is chemistry. This is what literally happens. Your atoms scatter. They rejoin the general circulation of matter on this planet, and they don't carry any memory of having been you. An oxygen atom that spent 20 years in your bloodstream is absolutely identical to every other oxygen atom in the universe. There's no stamp on it, no serial number, no trace. Within a few decades, your atoms are everywhere. In the rain, in the ocean, in wheat fields and pine trees, and the breath of strangers. You get redistributed across the surface of the earth. And here's where the horror comes in. Because you might think, well, at least my atoms are still out there. Maybe someday they could be reassembled. Maybe in principle some fantastic machine could gather all those atoms back together and put them in the right arrangement and bring me back. No, it can't. And I can tell you exactly why. The second law of thermodynamics doesn't just say that things tend toward disorder. It says something much stronger. It says that certain processes are irreversible. The entropy of a closed system can never decrease. Once disorder has increased, you cannot undo it without adding even more disorder somewhere else. Think of it this way. Imagine you drop a wine glass and it shatters into 1,000 pieces on the floor. Now, in principle, every shard is still there. You could, if you had infinite patience and perfect glue, put it back together again. But here's what you can't recover. The sound, the heat generated by the impact, the tiny vibrations that spread through the floor, the kinetic energy of the fall got converted into sound and heat, and that energy dispersed into the environment. It spread out among trillions and trillions of air molecules and floor molecules, each one getting a tiny, immeasurable nudge. Getting that energy back, collecting it from all those molecules, is not just hard, it's impossible in practice and essentially meaningless in theory. The same is true for the pattern that was you. It's not just that your atoms scattered, it's that the information, the specific arrangement, the dance, all of it got converted into heat and simple molecules and bacterial biomass and gas. The information that described you was written, effectively, in a book, and that book didn't just get torn up, it got burned. The smoke dispersed, the ash blew away. There is no recovering that information, not in principle, not with any technology. The second law forbids it. That is what physics says happens after you die. Not just that your body breaks down, that the pattern, the only thing that was ever really you, the dance that the atoms were doing, gets erased, permanently, irrevocably, converted into heat and waste and scattered across the planet. And this should change how you think about being alive. Because right now, while you're listening to this, that pattern is still running. Those 7 billion atoms are doing the dance. The choreography is intact. The whirlpool is spinning. And it took the universe 14 billion years to produce the particular pattern that is you. Stars had to be born and explode. Heavy elements had to form. A planet had to cool. An ocean had to churn. Life had to crawl out of the mud and evolve for 4 billion years. All of that just to get the atoms into the arrangement that can sit there and wonder what it all means. I once wrote that the atoms come into my brain, dance a dance, and then go out. Always new atoms, but always doing the same dance, remembering what the dance was yesterday. And what I find most astonishing is not that the dance ends. Everything ends. What astonishes me is that the dance happens at all. that a collection of atoms, each one as dumb as a rock, each one blindly obeying the laws of physics without the slightest awareness of what it's participating in, can come together and produce something that looks up at the stars and says, I wonder. The answer to what happens after you die is the universe takes its atoms back, every single one, and it doesn't ask permission, and it will not give them back, not in that arrangement, not ever again. In the entire future history of the universe, from now until the stars burn out and the last black hole evaporates, there will never again be the precise pattern that is you. The dance will be danced once and only once. Thermodynamics guarantees it. And I don't know about you, but I find that equal parts terrifying and exhilarating, because it means this isn't a rehearsal. There is no second performance. The atoms are dancing right now. The choreography is running right now. The pattern that took 14 billion years to assemble is doing its thing at this exact instant, and it is aware of itself, and it is listening to a fellow pattern talk about how patterns end. What are you going to do with it? That's what I'd like to know.